Find the value of the ordinary annuity at the end of the indicated time period, rounding to the nearest cent. The frequency of deposits is the same as the frequency of compounding. The amount is $1,000. It's invested at 5.5% compounded quarterly for a total of 8 years. Now they're saying this sort of to emphasize what an ordinary annuity really is. That's the only kind of annuity we're dealing with, so I don't know that that's that much to think about as you're working the problem. But when they say at the end of the time period, that's the way ordinary annuities work. You deposit at the end of a compounding period, and the frequency of deposits for an ordinary annuity is always the same as the frequency of compounding. So they're sort of just emphasizing what an ordinary annuity is, but since that's the only type of annuity that we're dealing with, that's not going to cause you to get or miss a problem, because all our annuities will be ordinary annuities. That's the way all ordinary annuities work. Anyway, getting that aside, I know that if it's an ordinary annuity, I have to use this formula for the future value of an ordinary annuity. And now it becomes an amount. It becomes a matter of just calculating the values, figuring out what everything is. I know that I need to calculate N, which is the number of compounding periods. And in this particular problem, I know that it's quarterly compounding, and that automatically means that M is equal to 4. Quarterly is 4 times a year. And I know it's for 8 years, so that's the value of T. So that tells me immediately that N is 4 times 8, or 32. Easy enough. I also need to know what I is. I is R divided by M. And I know that the interest rate is 5.5%, so that's R, but I do need to change it to a decimal as I write it down. So that becomes 0.055. Notice I moved the decimal place 2 places to the left. And divided by M, as we said, M is 4. So to calculate little I, we simply go to the calculator and enter 0.055 divided by 4 equals, which gives us 0.01375 for I, and I'll write that down. Now you can keep these values in the calculator, but sometimes you need them more than once, and unless you want to store something in memory, it's not a bad idea to write these intermediate results down, even though they are in the calculator. Okay, so we're ready to go now. The future value A is capital R, which is the periodic payment. Well, the amount they put in periodically is $1,000, so that's the periodic payment, times the quantity 1 plus little I, which we've already calculated to be 0.01375. That's raised to the power of N, which we calculated to be 32, and then 1 is subtracted from that quantity, and then the entire thing is divided by little I, which is 0.01375. Now it just becomes a calculator problem pretty much. So let's take this one thing at a time. The first thing I want to do is add 1 to the result that's already in the calculator. So all I need to do is take the calculator displayed value, which is the decimal part, and say plus 1 equals. And obviously I get 1.01375. Next I need to raise that to the 32nd power. So I want to do this entire exponentiation, the base is already in the calculator. So all I need to do, since the base is already there, is hit the exponentiation button, x to the y, then put in the exponent, which is 32, and click equal. I get 1.48059864. Looking back at the calculation in progress, the next thing I want to do is subtract 1. Since the exponentiation part is already in the calculator display, I just need to do minus 1 equals. I get 0.05408059864. Again, looking back, that quantity needs to be divided by little I, which is 0.01375. So I simply take the displayed value and that's already in the calculator and say divided by 0.01375 equals, which gives me 39.85889921. Now that calculation needs to be multiplied by 1,000, but I've just sort of gotten in a habit of writing down that particular intermediate step. As I said earlier, if you play your cards right, your calculator holds the intermediate values that you will need as you go, but there's certainly nothing wrong with writing them down either. In particular, I like to write that one down. If I have to trace a mistake back later, it just gives me one more thing to look at. So like I said, the only thing left to do to calculate the future value is to take the displayed value and multiply it by 1,000. So it will be times 1000 equals, I get 39858.89921. The problem asks us to round the final answer to the nearest cent. So that would be $39,858, and this 9 after the first 9 is the cents place. The digit following that is also a 9, which rounds the 89 up to 90. So to the nearest cent, if I put $1,000 in each quarter for 8 years into an account paying 5.5% compounded quarterly, at the end of that 8 years I would have $39,858.90.